If you've been watching my previous videos, you probably have learned a lot of techniques about how to capture images that is best suited for your machine vision application. But once you capture the images, processing them is a very important step. The hot technology that helps you with machine vision image processing today is deep learning. Hi, my name is Raghava Kashyapa and I'm CEO of Qualitas Technologies. And in this video, I'm going to break down the different types of problems you can actually solve using deep learning. The basic building block of a deep learning algorithm is, as you guessed it, a deep neural network. Right? So why does deep learning derive its name from? It's because the network that is used to process these images with a deep neural network goes with many different layers and thus making it deep. Okay, so that's the technical mumbo jumbo. But how do you actually apply this for industrial use? And there are three different types of algorithms or problem classes, if you will, that you can use deep learning to solve your machine vision application. The first one is called classification. And in classification, you are processing the image at the entire image level. So what do I mean by that? So the algorithm is responsible for taking an image and then deriving a class or giving it a class based on that entire image. So an example could be you're looking at a particular model of a car and it identifies whether this is model A or model B, and it takes the entire image as input and processes it to understand the difference between the two. And you could have many different classes, and that makes it a multi-class architecture. The next kind of problem type is what is called object detection. And here you're not looking at classifying the entire image, but you're actually going a little deeper and identifying specific objects that are present in the image. So in this particular example, it could be the different parts of an internal parts of a refrigerator, like the shelf or the freezer compartment or a manual that's present. And so here it identifies the location as well as the presence of that object. Now, the third is going a little bit deeper, and this is analyzing the image at a pixel level. And this is called segmentation. And in segmentation, you really have two types of segmentation problems. You can have instance segmentation and semantic segmentation. Semantic segmentation, each pixel is analyzed to identify if they belong to a certain class. So in this particular example, it could be whether each pixel is part of a vehicle, a part of the road, or as part of any other object present on the scene. So you're really going at not just identifying the object in a bounding box, but you're really trying to classify every pixel that's present on this particular image. The instance segmentation problem type takes it a bit further, and here it not only classifies whether a pixel belongs to a pedestrian, it also tries to identify different instances of different pedestrians present on the image. So for instance, if you have 5 different pedestrians or people, then it classifies each of those 5 as a separate instance and gives you that information. We actually used in industrial machine vision. Let's take a look at all the three problem types. So classification. So here again, as a reminder, you're looking at an image and then identifying a class for that image. And the typical applications could be identifying a particular SKU. So let's say you're doing an incoming stock inventory and you're trying to identify which of that SKU is actually coming into your material line. So here it takes an image, and then from that entire image it identifies that this belongs to SKU A. If the features within an image is broad enough or visible enough in relation to the entire image, then you could also use it for kind of classifying whether something is defective or not defective. So if the defect features, for instance, are pretty big, then that could also be an easy way to train a neural network to identify whether something is good or bad. Object detection, classic example could be assembly verification, identifying if all the engine parts within an engine body is actually present. So segmentation problems are typically defect detection. So let's say you have a smooth surface and you're trying to identify a scratch or a dent. And there, the scratches and the dents can be pretty small. And so here you have to identify which pixels of that entire surface in that image constitutes a defect. In order for the machine learning algorithm or the neural network to do the identification, you have to train this algorithm to actually do the detection. And the process of training is called deep learning, machine learning, or deep learning training. And the training process involves a technique called supervised learning. A supervised learning technique is teaching by examples. So you give it sufficient examples of the different types of classes or different types of varieties of images that you wanted to identify, and then you teach it with those examples, and the neural network builds a specific model that helps you then predict any kind of future images that are then asked of it to be identified. So, as you can imagine, for classification, the training is really about giving it an image and then giving it a class. So it's a very easy teaching process because it's really at the image level that you're trying to train the model on. The object detection goes a step further, and you have to teach it specific objects that you want it to detect. And so there, it's using bounding boxes as a typical technique to identify each object and then allowing the model to learn each object within that image. In segmentation, it's a lot more detailed. So as I said earlier, it's pixel-based teaching. So here you have to identify each pixel or classify each pixel within that image, and then the model is going to learn from these examples. So depending on whether you want to classify an image, identify an object, or actually classify each of the pixels, you can have a model, a deep learning model, or a technique that can allow you to do that. And these are finding a tremendous use in machine vision. And as algorithms are getting more powerful and more intelligent, and so are the applications, the possibilities of different applications that can be used in industrial machine vision. Next time you see a challenging application, do give deep learning a thought, and you'll be surprised at what you can come up with. Thanks. I hope this video was useful. Have a great day.